All right, so we are starting chapter 3. Okay, so first chapter of the term we solved equations. Second chapter of the second chapter we solved inequalities. Now we're going to start looking at functions. Okay, relations and functions. So that gets into like drawing lines, finding slope. You might have heard words domain and range. We're going to talk about those. How many people have heard of those before? Domain, range. If you've heard of input, output, it's the same idea. But I just want to look at an example first, okay, and then we'll get into the guided notes. I think you guys already have this printed on your guided notes. So it says Ann worked as a lifeguard for $7 an hour. Okay, so if she worked 1 hour and she made $7 an hour, how much money would she make?
$7.
$7. What if she worked for 2 hours?
$14.
She'll make 14. You basically just take 7 times how many hours you worked. So if she worked for 3 hours and made $7 an hour, she's going to make $21. So what we can do is we can kind of take this like 1 and 7, and those go together. 1 hour, $7. 2, 14. 2 hours, $14. They go together. So what we can do is kind of write them as coordinates, right? And that's, when we did coordinates here, these coordinates didn't really mean anything. It's not like if you worked 1 hour, you made $5. This 1, 5 didn't mean anything because it wasn't a word problem. But now we're going to write coordinates that actually mean something. So those 4 coordinates, you want to fill them in on that first line. So this is hours, and this is money. So sometimes coordinates have a meaning. In this case, the first one, which we call x, is how many hours you work. And the second one, which we call y, is how much money you make. All right. How about if I did one more? What would be the next coordinate if she worked 5 hours? 35. What's nice about the coordinate is it's a very quick way of writing down information. Right? Instead of writing out this whole sentence, in 1 hour she earned $7. We can just write 1, 7, and we're good. So it's a lot easier to just write that down. Let me just pass that back to you. So when you write down a bunch of ordered pairs, okay, there's a name for that. Okay, so on that first blank, you want to fill in relation. Okay, so a bunch of ordered pairs, that's called a relation. And it kind of makes sense because there is a relationship here between how many hours you work and how much money you make.
Wait, what about the S equals?
Yep, we did that one up above.
Oh, I see.
Right, so there's a connection. So that's what a relation is. It's a connection between 2 things. In this case, time and money. Now, the first coordinates, right, the 1, the 2, the 3, the 4, those values are called the domain of the relation. Right? So the set of all the numbers that are before the comma, the ones I circled, those are called the domain. Another word for that is also called input. It's called input. So, can someone tell me, we just circled them, but what did I just say that the domain was?
Input.
For this set S.
Oh, the hours.
And what were they exactly?
1, 2, 3.
1, 2, 3, 4. Yep, and that's what you'd write down. So, on the line that says domain equals, it was 1, 2, 3, 4. The domain is just a list of all the first numbers. 1, 2, 3, 4. I added a 5th one, but we don't have to add that one. Now, does anybody know what the name of the second coordinate is called? First coordinate is the domain, yeah?
Do you mean like what they'd be?
Yeah, I'm looking for the word that I'm going to put right here.
Oh.
And then we'll talk about what they actually are.
Range?
It's called the range. Yep. So the set of all the second coordinates, okay, you guys got a spot to fill that in, that's called the range. If you wanted to think of it as a letter, it's the y's. The first one is the x's, the second one is the y's. So now I want to go back up and look at our example and write down what the range is. It's going to be a list of 4 numbers. How about Kelsey? What's my range in set S?
7, 14, 21, 28.
Perfect. 7, 14, 21, 28. 7, 14, 21, 28. So on the line that says range equals, go ahead and just fill in those 4 numbers. So any question between the difference between domain and range? Domain is the first number. Range is the second. Now, these are pretty small, right? There were only 4 numbers in the domain and 4 numbers in the range. I mean, you could have thousands and thousands of ordered pairs. Okay? You could have a lot of them. Say, like, you wanted to make an ordered pair for every student in the school, where, like, the first number, the domain was ID number, and the second number was maybe they're going to keep track of, like, male, female. So you'd have ID number, comma, and you could use an M or an F, or maybe you'd use a 1 or a 2 to make it all numbers. Like 1 is, female, 2 is male, or something like that. But those would be a lot of ordered pairs. Okay, there wouldn't be a lot of values in the range, but in the domain, every single ID number in the school. So it'd be a lot of different numbers in the domain. So let's look at this one. I think you guys got it printed. There is a grid there. You can't see it. It didn't photocopy on your page. Usually when I ask you guys to find domain and range, we're going to try to make it so the numbers are nice. Not like 1.4 or something like that. All right, so what we can do if we want is let's label these coordinates first. How about Stephen? Can you give me the coordinate of that dot in the upper left?
-1, 1.
Perfect. -1, 1. Joe, how about this coordinate? Right there.
0, 0.
Yeah, 0, 0. That's a special one. That's called the origin. Okay, we'll probably mention that a little bit later, but if you didn't know, now you know. That's called the origin. How about that coordinate? Caleb?
1, -1.
I agree. 1, -1. And the last coordinate, how about Tristan?
2, -2.
2, -2. Yep. Okay, now we've got all the numbers. We can write the domain and range. So Lucas, let's start with the domain. What numbers are you looking for in the domain? The first one or the second one?
First one.
First one. So what I'm going to do is I'll underline it in green, and I'll circle all the first ones in green. So can you tell me what my domain is?
-1, 0, 1, 2.
Perfect. -1, 0, 1, 2. Okay, now let's do range. How about Gianna? Range, is that the first one or the second one?
The second one.
Second one. So underline that one in blue. All these numbers are part of my range. So can you tell me what my range is?
1, 0, -1, and -2.
1, 0, -1, -2. You don't have to put it in numerical order. Okay, that's fine.
So it can be in like any order.
Yeah, it can be in any order. Also, let's say you had another dot. I'm going to erase this. Let's say you had another dot right there. Well, that coordinate is -1, -2. Let's look at the range there. -2, there's another one that's -2. If the same number happens twice, you don't have to write it twice. Once you say that a number is in the range, that's good. You don't have to say it again, right? So if that ever happens, remember, you don't have to put repeats.
Is it bad if you do?
You know, it's not wrong if you put it, but you don't have to. Okay, but it's not wrong. It's just kind of like if you were to solve a problem on a test and you told me x equals 3, and then right below it you wrote again x equals 3. It's like saying the same thing twice. That's all. Okay. So any questions on finding domain and range? Okay, let's look at this one. Okay, I think this one's a little easier because you don't have a picture. They already gave you the numbers. Okay. When I don't have the numbers, that's the first thing I always do. Figure out the coordinates. Okay, so yeah, we've already got all the numbers. Can somebody tell me what the domain is here? Joe?
2, 0, -1,
2, 0, -1,
3.
3. Perfect. Domain. Can somebody else tell me the range of this relation? Okay. We don't know what this relation means. Like, what does 2, 1 mean? We don't know if that's from a word problem. Like, if you buy 2, how many you get free? You buy 2, you get 1 free. We don't know. We don't know what it is. It's just numbers. But what's the range here? Yep.
1, 0, -2, 6.
Yep. 1, 0, -2, 6. Notice the name. You can call the relation anything you want. You can call it M, S. It's just a name for all those ordered pairs. Any questions on how we got domain or range there? All right. Now, if you take a look, in both of the previous examples, none of the first coordinates were ever the same. 2, 0, -1, 3. No repeats in those numbers. Okay. -1, 0, 1, 2. No repeats in any of those numbers. Okay. If the first coordinates never repeat, that's special. Okay. Something special happens. And when that happens, your relation is a special kind of relation called a function. Okay. So when none of the first coordinates are the same, that is called a function. So, where it says in a function, you guys get some lines, you may have repeats in the second coordinate. That's fine. Second coordinate can repeat all you want. It's the first coordinate that can't be the same. Okay, so in a function, some of the second coordinates may be the same, but no two coordinates can have the same first number. Okay, no two ordered pairs can have the same first number. If you're trying to answer the question, is it a function? And the answer is either yes or no. So as long as this happens, then you're good. You've got a function. So now what I'm going to do is I'm going to ask you guys kind of like the same question you just did. I'm going to ask, okay, what's the domain? What's the range? But then I'm going to add one more part to it. Is it a function? Okay, so remember, for a function, no repeats in the domain. No repeats. Does everybody have that written? Okay, so let's take a look at example 2a. Okay, so here's our relation. How many ordered pairs are in this relation? 5, yep. It's got 5 different coordinates, 5 different ordered pairs. Those two words mean the same thing. So it says determine the domain, determine the range, and then is this relation a function? Okay, so you guys have to fill in, you've got a line where you can fill in all the different coordinates. Okay, let's start with the domain. Anyone think they can tell me what the domain is for this relation? Yep, Aileen?
1.
Yep.
-1. 2. -2. 3.
Yeah. 1, -1, 2, -2, 3. Perfect. So we've got the domain. How about Jayliana? What about my range?
-3, 3, 5, -3, -1.
All right, so she said -3, 3, 5, -3, -1. Okay. Anything about that range that I mentioned it, that's okay, you can do that, but
You don't need to -3.
yeah, when you're making a list of all the numbers, you don't have to put -3 twice. So if you put that, that's fine. If you put that, that's exactly the same answer. You've told me -3 is in the range. You don't have to tell me twice. Sometimes that's hard to do. Like if you had thousands and thousands of numbers, how would you remember which ones you've already written? You'd have to go back and check. With 5, it's not that bad. Okay, so now, is this a function? That's either yes or no. Yeah.
Yes.
How come though? I had a repeat in the range.
The domain doesn't have any repeats.
Right, it's the domain that can't have any repeats. And did the domain have any repeats here? 1, -1, 2, -2, 3? Nope, we're good. So if you don't have any repeats, then that's called a function. So think of a function. It's a special kind of relation. Right? Even if it wasn't a function, it could still be a relation. Right? It just means that there was a repeat. Right? But if there's no repeat, that makes it a function. Right? Any questions on that one? Okay, let's take a look at this one. Okay, so let's start with domain. Okay, so this time the relationship G, it's made up of 3 coordinates. Okay, so Mackenzie, what is my domain here?
6, 4, and 4.
Yep, so what could you write if you wanted?
You can just write 6.
You could just write 6 and 4. Remember, the domain is just a list of every number that's in the domain. All right, so we got the domain. Blake, how about my range?
3, 2, 1.
3, 2, 1. Yep, I agree. Is this a function?
No.
No, why not?
So there's a repeat in the domain.
There's a repeat in the domain. Is it still a relation?
Yeah.
Yeah, of course, it's still a relation. It's just a bunch of coordinates are a relation. But to be a function, it has to be special. You can't have any repeats in the x's. 6, 4, 4. That's a repeat. Okay, so that's not a function.
Wait, so it's only a function if there's no repeat in the x?
Yes. Yep. No repeats are allowed in the x for functions. Okay. Any questions on that one? Right. So you guys have seen a few different kinds of problems. I can give you a picture and ask you all these kinds of questions. I can give you just a list like that and ask you questions, or I can put it in a table and ask you the question. Okay, all different ways of kind of representing the same information. How many coordinates does this table represent? Yeah, 4. Represents 4. This is the first one. That's the second one. Third one. Fourth one. Each coordinate has an x, which is your what we call input, and a y, which is the output. Okay. This time you don't have to tell me the domain and range. I just want to know if this table is a function.
Yes.
Yes. -6, -2, 4, 5. So yes. There are no repeats in the domain. So you've got 3 different names for the same thing. You can call this domain, you can call it input, or you can call it the x's. It's all the same. You can call the bottom one the range, you can call it the output, or you can call it the y. It's all the same thing. Okay. Any questions why that one is a function? No, yeah, why it's a function. Okay, so we got the graph we can do, we've got the list, we've got a table. One more. This is like a diagram. It's a mapping diagram. I'm going to make those bigger so you can see them. On the left are the inputs, on the right are the outputs. We don't have to write them all, but anyone think they can tell me what the coordinate would be for that first one? If you were just going to write it like this.
-7, 1.
Yeah, -7, and what's the y?
-1.
-1. That's all. That's all that
Would we
means.
have to like draw this?
Usually I would give you this picture and then ask you this question. Determine if it is a function.
Okay.
So if it helps, because you're confused looking at this picture, write every single coordinate down. Right? Like the next one would be -1, 1. Then you could have 4, 3, 4, 5, 9, 7. All of this is just that. That's what that means. So, Mike?
Can I go to the bathroom?
Yeah.
How does 4 equal 2?
How does what?
Like, how does it do?
I can show you what it is in the YouTube.
Oh.
So what do we think? Is this a function?
Wait, no, I have a question. Wouldn't you be able to tell if it was a function just by looking at like the 2 ovals?
Yep, you can.
So then why would,
You can write coordinates if these confuse you. So if you don't like this and you're like, you know what, I just like to see coordinates, that's fine. You can write this as
but
coordinates.
so you only have to look at the x's?
Yes. Yep. All you have to really do is look at that left oval and you can tell.
Okay.
Is it a function?
No.
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 Not a function. Why? Yep.
Because the 4 repeats in the input.
Yes. The 4 is a repeat. The way you can tell it's a repeat in this diagram is you have an arrow here saying, okay, match up 4 with 3, and you have an arrow here saying, match up 4 with 5. You're matching 4 up with 2 numbers, so you're using it twice. No, that's not a function. Now, what if I have this? Let's just do 1, 2, 3, and 4, 5, 6. Let's do this, that, and that. We don't even need this number. What do you think now? Is that a function?
Yes.
Yeah.
Yes. What's happening here is there's a repeat in the y. Right? If you were to write these out, that's 1, 4, 2, 4, 3, 5. Look at the x's. 1, 2, 3. No repeats. Y's, yeah, there's a repeat. 4 and 4. We don't care about the y's repeating. That's okay. Just as long as there's no x's repeating. Right. So in the diagram, the way you can tell, do you have 2 arrows coming from the same number going to the right? If you do, like this, that's a problem, not a function. If you have two arrows going into the same number, that's okay. That's not a problem. Okay, so any question on that? All right, so this one right here, everyone agrees is not a function at the top, right? All right, let's graph. I just want to graph those coordinates and show you what happens. So the first coordinate was -7, -1. So -7, -1. We had -1, 1. -1, 1. 4, 3. 1, 2, 3, 4. 1, 2, 3. Again, these probably aren't going to make a straight line. They're just random points. 4, 5. 1, 2, 3, 4, 5. And 9, 7. 9, 7. I think it's right there. Okay. There's something special that happened with two of those dots. Anybody tell what happened with two of them? Elizabeth?
Isn't it they have the same x-axis?
Kind of on the right idea, but not. We're not thinking left to right. X-axis is left to right. Yep.
They're on the same line.
Yeah, two of them line up vertically, like that. If you got rid of one of these, that wouldn't happen. Either this 4, 3 or 4, 5. If you got rid of one of them, none of the dots would line up and down. This is how you can tell something is not a function if you have a picture of it. If two of the dots are lined up perfectly, up and down, that's no good. That's not a function. You can't have two dots lined up like that. And there's a name for that, and that's called the vertical line test. Okay, so under vertical line test, two points. The first one, it says that this is used if you want to figure out if a graph is a function, just by looking at it. All right, so this gives us kind of a shortcut. We don't have to write down all the coordinates. So, if you can draw a vertical line, and no matter where you put it, it would only hit one dot, that's what you want to happen. That's a function. If you draw a vertical line, and it ever hits two dots, that's no good. Or 3 or 4. No good. All right, so if I take, just for example, take a vertical line, right, and I start dragging it along my graph, I'm going to check, does it ever hit two dots at the same time? Nope, only hits one. Nope, only hits one. Whoop, problem, it's hitting two at the same time. Right? If a vertical line could hit two anywhere, doesn't matter. It doesn't have to happen in a lot of spots. It just has to happen once, like right there. That is not a function. We would say that this one fails the vertical line test. Okay. So let's see. Can I just drag this over here? Yep. All right. Let's look at this one. Let me make it bigger. Okay. So. Let's make that a little thinner. All right, so as I drag it, look at this picture. Is it ever hitting the black curve in more than one spot?
No.
No matter where I put it, it never hits it in more than one spot. Now, let's go over to this one. Is it hitting it in more than one spot there?
No.
No. How about there?
No.
How about there? How about there? How about there?
No.
Okay. How about there?
Yeah.
All right, that's a problem. So this one is what we call a function. This one, not a function. That's probably one of the easiest questions you're going to have on the test. Right? if you've got a graph and you can put a vertical line and it hits it more than once, not a function. If it never hits more than once, function. So it's just another way to tell if something is a function when you've got a picture of it. Okay? If we had coordinates, that's when we're looking for the x never repeating. Right? But this is more of like a visual. So let's look at this one. So example 3a. It says determine whether the graph represents a function. Okay, so if I take a vertical line, and this time the dots aren't connected. They could be connected, they could just be dots, doesn't matter. Is it hitting the graph more than once there? No, in fact, it's not hitting it at all. How about there? How many times does it hit?
Once.
Just once, not at all, once, not at all, once, not at all, once, once. Does it ever hit twice?
No.
No. So is this a function?
Yes.
Yes, it is. We say that it just passed the vertical line test. And that's what you can write for explain. So this graph passes the vertical, we can just abbreviate it, VLT, vertical line test. This graph passes the vertical line test. Okay. What if I connected them like that? Would it still pass the vertical line test?
Yeah.
Yeah. What if I connected them like this?
No.
No, because now you've got a little problem right here. If you put a vertical line, it hits more than once. Okay. These weren't connected, so you didn't have to worry about that. Let's look at this one. 3b. Does this pass the vertical line test?
Yes.
Yeah.
Yes. Take a vertical line. No matter where you put it, it's only hitting it one time. So is it a function?
Yes.
Yes. Why?
It passes the vertical line test.
Passes vertical line test. So yeah, these ones take up a lot of space. That's why they're now we're on the last page. Okay, how about this one? Is it a function?
No,
No. Why not?
it did not pass the vertical line test.
That's one place I could draw a vertical line and it hits more than once. Okay? In fact, everywhere it's going to hit more than once, except right in the middle it doesn't hit at all. So this is not a function. All right, so does not pass vertical line test. Okay, and just to show you, let's write down a coordinate, like this one right here. And let me write down this one. I want you to tell me what happens. That coordinate is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, comma 6. This one is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. If I just gave you these two coordinates and said, is that a function? How would you know it's not?
Because the x is the same.
Right, you've got a repeat. 6, 6. Can't have any repeats in the x's.
Whoa.
Okay? So the vertical line test is the same thing as looking for repeats in the x's. It's a visual way to do it, rather than looking at numbers. Okay? Yep.
Can I go to the bathroom?
Yep. Okay. I think that was the last one for that. Let's look at this one. Find the domain, range, and then tell me if this is a function. All right, now, this one's a little different than just dots, right? What's different here, it's not just dots, it's what? It's all connected, right? So the domain is basically everything that's connected left to right, okay? Everything. So like 1 is in the domain, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. They're all in the domain. So when you have something that's connected, it's a little different the way we're going to write the domain. Now, look at the end of this graph. What kind of circles are on the end of it?
Open.
Open. Does open mean you include or don't include? Don't include. Okay, remember from inequalities, filled in means include. Open means don't include. So, when we do the domain, what letter is the domain? X or Y? X. Okay. So we're going to start with an X in the middle. Now, look at this graph. And can somebody tell me what's the farthest to the left that this graph goes? Negative. Well, the grid goes to -5. Does the graph go to that? No. What does the graph go up to? Include -4 or no? No. So what you're going to do is we're going to put a -4 there. And what we're saying is the domain is all numbers that are greater than -4. So greater than -4 means to the right. But does it go to the right forever?
No.
No. Can somebody tell me where does it stop on the right side?
5.
So the grid stops at 5. But what's the farthest to the right that this graph goes?
4.
4. Just imagine a vertical line right there. It stops right at 4. Does it include 4?
Yeah.
Include means it's a filled-in circle. No. This would include 4. Like that. Right? This is an open circle. So 4, and that's how we write the domain. So it's kind of like what we did with inequalities. Put the letter in the middle, and we're saying that x has to be greater than -4 and smaller than +4. Right? So it's kind of like if you had a line like this, and you're saying, does it hit here? Yep. Here? Yep. Here? Yep. Here, 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 here. It hits everywhere between -4 and +4. That's my domain. X's, left to right. Now we're going to do the same thing for the range. That's up to down.
You got the -4 and the 4 from like the ends.
Yeah, I just kind of looked. I said, okay, this graph is between -4 and +4. That's my left to right. Now we're going to do up to down. So what's the letter that we use for range?
1.
Y. And remember, smallest number on the left, bigger number on the right. What's the lowest that this graph goes on the Y's?
-3.
Does it actually hit -3?
No.
No, we don't include -3 unless it was filled in like that. Okay, but it's not filled in. So -3 is the smallest. Now, what's the highest? Remember, range is up and down. What's the highest that we go?
1.
Um,
5.
So 1 would mean we stop right there.
5.
Yeah. The highest we go is 5. Remember, both signs point to the smaller number. Should I include -3?
Yes. No.
No, because it's open. Right? So what that open means is like if you zoomed in, it's stopping just before -3. Right? It's not actually hitting it. Like if this was -3, the graph is coming down, and it's like it's stopping like right there. You can't even really see it, but there's a tiny gap. Doesn't actually reach it. Okay? If I make it bigger, you can probably see I stopped just before -3. All right, so we don't include it. How about 5? Does the graph reach 5?
Yeah. No.
No, it's an open circle, which means the graph stops just before 5. Right, so the range is every single number between -3 and +5. So whenever you have a graph that's connected, that's how you have to write the domain and range. right? If it was just individual dots, like that, then I would just say, oh, I just write down what the coordinates are for those dots. But these are all connected. Now, last question, is that a function?
Yeah.
Yeah. Vertical line would never hit more than once. So yes, that is a function. Okay, that one's a little tricky, but any questions on it? Yeah. What, can somebody tell me, there isn't much I would have to change, but what if I did this? What would change now? Let's start with the domain. I'd have to do one thing in the domain. Yep.
You'd have to put like the equal sign under the mark.
Yes, we'd have to. So if I make that a filled in dot, Maya was saying, where would you put the equal to under?
Under the -4 side of
Yeah.
the mark thing.
Right?
And
Right here.
yeah.
So if you had a filled in circle, you'd say, okay, it's equal. And where else would you put it?
Under the -3's mark thing.
Yep, under the -3, because now it includes -3 and it includes -4. But we didn't have any filled in circles, so I'm just going to leave it the way it was. Okay, and we'll practice more of those, but that's how you do it. All right, so somebody tell me another name for X we've used.
Input.
Input, yep.
Domain.
Domain, right? X input domain. Well, there's one more. This is the final one.
Independent variable.
Yep, independent variable. This is the last different name. Okay, I promise. We're not going to keep having different names. This is it. How about another name for Y?
Dependent.
Dependent.
Output.
Right? Yep, we've said output. We've also said range. Now we're going to say dependent. So you guys got a spot towards the end of your notes before the last example. Independent, dependent. Right? This can be a little tricky to figure out what's independent and what's dependent. Right? So we're going to have to figure it out because in a word problem, one of the variables is always two. One of them is independent, one of them is dependent. And you can't switch which one is which. So here's an example. We're going to just go through this together. You can just watch this part, and then we're going to write one down. So let's say that I made $11 per hour. Okay? $11 per hour. So there's two things here. There's how many hours I work and how much money I make. So first thing we would say is only one of these is going to make sense. So the first thing I'm going to ask you is, does how much money I make depend on how many hours I work? Or does how much I work depend on how much money I make? One of those makes more sense than the other. Which one makes more sense? We'll say the first one or the second one? Yeah? The second one. How much I work depends on how much money I make. So like if you go to your employer, they hand you a bunch of money first, and then it controls how much you work. Does that make sense? How much I work depends on how much money I make. Think like, you don't get like, it's a little tricky to explain, but the first one is the one that makes more sense. How much money you make depends on how many hours you work. Right? Think of like an employer. If you ask your employer, how much money am I going to make this week? They would say, well, it depends on how many hours you take. The more hours you take, the more money that you're gonna get. So how much money you make depends on how many hours you work. Right? The other way, to me, the second way doesn't really make as much sense. How much I work depends on how much money I make. Right? I try to think of what's in control here. All right? What controls what? the amount of hours you work controls how much money you make. How much money you make doesn't control the hours you work. Does that make sense? Right? So what we'd say here is money is dependent on hours worked. Money is dependent. Pretty much any problem that we do, money is usually dependent. Money depends on something. Usually it's how many hours you work. Right? Let's say I gave you guys an example of time spent studying and grade on a test. So time versus grade. Now, which one do you think would make more sense? Let's say I said to you, does the grade you get on a test depend on how much time you study? Or would you say how much time you study depends on the grade?
The first one.
The first one, yeah. How much time you study depends on the grade? Doesn't even really make sense. How much time you study depends on the grade. That doesn't make sense. The grade depends on how much you study. Right? Assuming the more you study, the better grade you get. All right? So here you would say grade depends on the time you spend studying. So grades are dependent. They depend on how much time you prepare for the test. So grade is dependent. Time is independent. Okay? Let's try another one. So this one is actually one on your notes. So this one says this formula. So you got a glass in front of you, right? It's filled with, what does it say? Juice. So you get a glass of juice. And it says this formula represents the amount of juice that's left in the glass after you take a certain amount of sips from it. Just to keep it simple, we'll assume that a sip is the same amount each time. Okay? Or however you want to think about it. But a sip is the same amount. So the two things we're looking at here are how much liquid is in the glass and how many sips you've taken. So let's see if we can identify the independent and the dependent. So first, the two variables are how much, let's see, we could say we have sips. That's going to be one variable, how many sips you take. And then the other one is going to be how much juice is left, okay, in ounces. So juice left in ounces. So now we just ask the question both ways. How much juice is left in the glass? Does that depend on how many sips you've taken?
Yes.
Yes, it does. That makes sense to me. How much juice is in the glass?
So
Well,
the
it
juices
depends
are
on-
dependent.
Yeah, so juice depends on how many sips you've taken. All right? The juice that's left in the glass depends on how many sips you've already taken. So, juice is your dependent. Which actually, you know what? We're going to write it right here. So, juice is the dependent, which means the independent is what? Sips. Right? Another way, like if you get a little confused, imagine you had like more liquid in front of you than you could ever drink, right? More than you ever could possibly drink. But it's not unlimited. Maybe it's just like 3,000 gallons. Like there's no way you're going to sit down for lunch and drink 3,000 gallons, right? So if I said how much juice is left in the glass depends on how many sips. Okay, that makes sense. Try saying it the other way. How many sips you take depends on how much juice is in the container. Not really, because we said that the container's huge, right? How many sips you take doesn't depend on how much juice is in the glass, right? It's the juice depends on sips. So it just takes a little practice to kind of get used to that. All right, so we've got that. What's the next thing they want? So, let's say that your juice here, you got a 12-ounce Gatorade. Find the domain and range of the function. All right, so we've got the formula. Y equals negative 3x plus 12. Now, to keep it simple, we're going to say like you can only take a whole sip, right? We're not going to say you can take like a half sip or a quarter sip or an eighth of a sip or a tenth of a sip. That's too confusing, right? Take a sip or you don't take a sip. So, do you have enough juice here to take one sip?
Yeah.
Okay, let's try it. So if we think we can take one sip, let's fill in this table. This is our formula. So if we take one sip, let's plug in 1 for x. So remember, x is my independent. And independent is always your x. That's always your y. Okay, so let's take one sip. What am I filling in for x? 1. Now I didn't do anything yet. Now I want to do it. What's negative 3 times 1?
3.
Negative 3. Plus 12? 9. How would you write that as a coordinate? Where x is your sips and y is how much juice is left.
1, 9.
Yes. If you take one sip, there'll be 9 ounces left. Do you have enough to take a second sip?
Yeah.
Let's try it. Y equals negative 3 times 2 plus 12. What's negative 3 times 2?
Negative 6.
Negative 6 plus 12. 6. How would you write that as a coordinate?
2.
Yep. Yeah. So what does that mean, 2 comma 6? If you do what, there'll be what?
If you take 2 sips, there will be 6 ounces left.
Yep, so 2, 6. 2 sips, 6 ounces left. Do we have enough for 3 sips?
Yes.
All right, let's try it. What's negative 3 times 3?
No.
Negative 9.
What's negative 9 plus 12?
3.
3. What's that as a coordinate?
3, 3.
3, 3. If you take 3 sips, there'll only be 3 ounces left in the bottle. Do we have enough for 4 sips?
Yeah.
All right, let's try it. Problem is, once we run out, we're done. Okay. Negative 3 times 4 plus 12. What's negative 3 times 4? Plus 12?
0.
0. So if we take 4 sips, how much is left?
0.
Nothing. Now, technically, there's one more thing we could have done. We can take 1 sip, 2 sips, 3 sips, 4 sips, or what else could we do?
Chug.
No, we can only take sips. We can only take sips. There's one other thing we could do, kind of simple, we didn't think of it.
Spit it back out.
No, you can't do that.
Throw it.
Yeah.
Pee back into the bottle.
And
Yes.
then re-drink it.
Guys, speaking of
Man.
morbid. Oh.
Yeah.
Solve the equation.
No, there's one more thing you could do. You could take 1 sip, 2 sips, 3 sips, 4 sips, or
I think the doctor said.
You get it?
no, you can't. You either can take a sip or you not take a sip. That's all you can do.
And then you'll have 12 ounces
What?
if you don't take 6.
If you don't take a sip at all. Okay? So an option technically is to take 0 sips. That makes sense. Maybe you don't like that flavor. You don't drink it.
Well, if you take, you won't know unless you take 1 sip.
No, you see, you would.
So what's negative 3 times 0?
0.
Plus 12?
12.
12.
Yeah, that's what I meant.
So
It's alright.
it might have made sense to do that one first. If you take 0 sips, there's 12 left. So now, somebody tell me what's my domain? If we can, let's put it in order, even though we're not in order.
0, 1, 2, 3, 4.
Right.
Thank you.
You can take 0, 1, 2, 3, or 4 sips. What's your range?
9, 6, 3. 0.
Yep.
3, 6, 9, 12.
Yep, range is how much is left after the set. 0, 3, 6, 9, 12. Okay, so it's a little tricky with domain and range sometimes to figure out what's independent and dependent. I'll try to help you guys more with that during the week. So homework is the worksheet on 3.1.